So I am now interviewing Jan Smith for the um, initial proclamation of this new project that's attempting to give a more sober view on chatbots, what's called artificial intelligence, and other such matters and their impact on society, both theoretical and applied. Jan is um, was a professor at Chalmers for a long time, and I guess you're now emeritus. But you also oversaw the AI competence for Sweden as a coordinator, which basically you can say more, but it distributed money to 10 different universities, and you also oversaw this Chalmers AI Research Center, which began around 2018. And so to begin, I'm going to ask you a question that's maybe a little bit esoteric, but I think quite relevant. And so on Midsummer's Day in 1989, you wrote the preface to a favorite textbook called Programming in Martin Löf's Type Theory. And you referenced having first taken the train to see Per in Stockholm 10 years prior. So my first question is, what are your recollection of these experiences, both the initial meeting, the publication of the book, and yeah, please take it away.
So Per Martin Löf was my thesis advisor, and I got my PhD in 1978. And soon after that, I got in contact with so that was in mathematics. But soon after that, I got into contact with the group here, which wanted to develop safe software or checked software in somehow to raise the standard of software development. And already Per Martin Löf had quite specific idea how type theory could be used for programming. So I gave a seminar on this, which must have been then 1979 or something like that, which made me contact with, in particular, Bengt Nordström. And then we, of course, I was, of course, careful that Per Martin Löf should be involved in this, since he really had these ideas before. So then Bengt and I took the train, as you say, to Stockholm, and we met for the first discussion there. And so it was really something very exciting, I would say, that this possibility opened up.
And so in the context of artificial intelligence at the time, did you, like, I remember talking to Per once, and he said that he considered himself a quote unquote applied mathematician, that type theory was in some sense applied mathematics. But did you think of this in the context of what was called AI back then? Or
No,
was
I don't
this totally orthogonal?
I mean, AI had a rather bad reputation among some of us. They were making enormous claims which they never lived up to, and there were several waves of it. And I would say that around this, it was really a low. I mean, there was really no AI worth talking about at this time, which is quite interesting because the ideas that we are used today, they were around then. But in my view, it all had to do that the computers were far too slow, and memory. I mean, there were nothing was working in favor for AI really. So when they started to do things, not much came out of it. And I think the explosion that we see now, it is mainly Moore's law that has led to this. And I mean, it's just incredible. The increase in data and increase in speed. It's just unbelievable that what has happened over these years since 1980, of course, but also lately this use of graphic cards and these things has opened up new doors. So I would say that in some sense the ingredients were here already around 1980, but it simply didn't work.
Okay.
And I think our group here had a rather negative view of it because nothing was really delivered.
Mm-hmm.
And no one, I think, at that time would have foreseen what has happened after that. And that's really, in my view, due to this enormous explosion of computational speed and data combined. So I think that.
But so one thing as well, just to kind of piggyback off that, is things like AGDA. Yeah, it's not required all these GPUs, but it does require a significant amount of computation that definitely wasn't available back then. So you can say that
Yes.
Moore's law also enabled a lot of the
Yes.
type theoretic revolution to happen as well, in some sense.
Yes. So the first systems that we work with, they were of course quite difficult to use because of slow computers or whatever you should call compared to what we have today. So that was really a lot has happened there too. But I don't think one really should compare it with the explosion of AI. It's a little bit like more ordinary Moore's law.
Yeah.
But with AI, something dramatic has happened during the last 5 or perhaps 10 years. But particularly the last 5 years, I would say.
Yeah. So yeah, let's interrogate this historically a little bit more. I mean, I'm not an expert on the history of philosophy, but and maybe that's not you haven't read everything either, but I don't know if you'd rather start with Descartes and the so-called language test, or Frege and the philosophy of mathematics and this kind of attempt to, yeah, bring natural language, logic, and mathematics together in some sense. And in some sense, you could see that as a progenitor for so-called artificial intelligence. I don't know what your reflections are on these initial.
Well, so Descartes' language and action test. I don't know about that.
Yeah. I mean, it's just a reference to kind of hypothetical machine that could somehow respond to human input and behave in a seemingly lifelike manner. But I don't think he wrote extensively about it. But I was reading the Stanford Encyclopedia article, and it was saying that apparently Turing was aware of this when he wrote.
So I should really look that up.
Mm-hmm.
Otherwise, I think the big name in this time was really, well, a little bit later, Leibniz, which. But Frege I know quite well, and well, I think he wanted to create a language for mathematics, as you say, a formalization of mathematics, and I can't see any connection to artificial intelligence there. But I must say, when I was reading these things, which were some years ago, I did not at all have the perspective of artificial intelligence. Perhaps if you have that, perhaps you can find things which I didn't notice when I read it.
I guess I just think of it in the context of Frege initiating the philosophy of language, let's say, and like inspiring Wittgenstein and Russell, and then that leading also to, Alonzo Church and Carnap, like all of these kind of behemoths that then laid the work for Turing, and then, what happened later after the war. So maybe not a direct connection, but definitely the seeds, let's say.
Yes, Frege was, of course, a very fundamental figure for all these things.
Okay. And then what about World War II? So we can see kind of a convergence of communications science, which had already begun in the earlier part of the century, the development of cryptography, semiconductors, information theory, Do you see this as kind of laying the gravel for what we call AI or computing generally? Like, should we decouple AI from computing only in the 50s?
I mean, Turing made his work. I mean, he died in 1953, wasn't it?
Yeah.
So it is, and of course, I guess that his experience with from the World War II with cryptography and so was very important for him. And he was obviously very interested in what we now call artificial intelligence.
Yeah.
He obviously is, and somehow I think but really I haven't read these things with this perspective. But he is at least the one that obviously is connected to artificial intelligence.
Mm-hmm. But so how does that relate to like Church and Gödel and the other people he was around? Like, did he bifurcate from them in creating AI? Do you think none of them had interests in creating some kind of intelligent notion from computing?
So Turing really stands out, and I don't know really if I can't remember seeing anything from Gödel about this, but surely he wrote a lot, and there might be things there
Mm-hmm.
which I don't know anything about really. But in general, I can say that if we look at our group in type theory around 1980 and onwards, we were really very negative about artificial intelligence because they were promising a lot and they didn't deliver anything.
And so maybe I'm a bit naive, but I guess most people from my generation are, is like, what did artificial intelligence mean in 1980 in your recollection?
Well, I mean, there were people who were making very strong claims about artificial intelligence. Which I think they were very, very far from fulfilling. And to me, the really great surprise is that one now seems to be on the way of fulfilling it.
Mm-hmm.
But it's really due to an enormous development of hardware, really, that lies behind. Because these ideas with neural networks, which of course are central to this, I'm not sure exactly when, but it was during the 1980s that people discovered these things and had ideas about it. So the ideas of what we see today, it was already there in the 1980s.
Mm-hmm.
But
Sorry, go ahead.
but the speed of what they were doing and the data they have available was very, very far from what we have today.
Yeah. I mean, because I don't remember when Moore's law even was prescribed as such, but
It was somewhere in late 1950s, I would guess.
mm-hmm.
Or
But
was
did you
it early 1960s, but something like that.
I mean, this was also the like 1980 was also the pre-internet era, and there were some proto-internet forms, but
Well, yes, I don't remember exactly, but I surely had email in 1980.
mm-hmm.
So I think it is around this period that it started.
Yeah. And did you
But
feel like the scaling of things was just going to increase? Because I think that's one of, yeah, the big takeaways from the last 70 years is there's been no kind of, one system scales exponentially and then new systems emerge from that and then they scale exponentially. And there's kind of this endless scaling happening. Do you feel like you were aware of just the magnitude of the scaling across computing?
I think one was aware of the magnitude of the scaling, but it was extremely difficult to predict what that would lead to. I think that's a very important aspect, that it's very difficult to predict what will happen when you get this enormous, I mean, Moore's law working for many, many years, exponential growth. It's just impossible to see what's behind the corner.
Mm-hmm.
And I think this, if you look very recently, this chatbots came as a real surprise to most of us.
Yeah.
And I mean, it's not much more than half a year ago.
Mm.
And I think
Well, I think that's when it entered the public zeitgeist.
yes,
but
yes, of course,
obviously,
that was work before, but still. And I'm sure that will develop enormously, and you don't know really where it will end.
mm-hmm.
Because there is so much money put into it also.
Yeah.
So many man-hours of work.
But so before we get to that exactly, I still want to look at like Turing's computational or computing machinery and intelligence, this publication where he introduced the
Yes.
so-called Turing test. And I'm curious, what are your reflections of the Turing test or a Turing test that like was his Turing test? I mean, it was just kind of an arbitrary experiment, but you can think of a million different thought experiments where you could have multiple actors, different rules to what they can or can't say. And I'm curious, what are your reflections on the Turing test, both as in and of itself and then its historical significance?
Well, it looks rather natural, perhaps, when you first see it, but I don't think it is at all sufficient to describe intelligence, something that can live up to the Turing test. I don't think that the present-day chatbots are not very far from doing that.
Yeah.
But they are certainly not intelligent. That's my view of it.
Mm-hmm. But I mean, yeah, like I think that is, people see the Turing test as some kind of, it's entered into the imagination of a lot of people as this kind of gold standard. But I think it's also, I think it was an important precedent in terms of defining some notion of computing goal in some sense, or an AI goal, but it wasn't, there was no notion of AI, like term didn't get invented or said out loud until 1956, I believe. But it's exclusive to language, so any animal is automatically, not going to be included in this Turing test. And in many ways, yeah, like animals are just as intelligent as humans, even if they haven't evolved a language capacity. So I don't know if you have anything to add on that.
I think the Turing test was was as good as you could produce at that time. I mean, I think it was very clever to come up with this rather simple idea. And of course, it would be impossible to see all the flaws when you create it. But now we, of course, have much more knowledge about this.
Mm-hmm.
But I think it was a very clever thing. And I guess that it is first now that we could think of perhaps have a chatbot that could get through the Turing test, and which I definitely don't think is intelligent, but nevertheless could pass that test.
Yeah. I mean, I guess it depends, because one thing I've been thinking about over the weekend is like, because if there's two human actors and one computer in the test, and the human actors, both of their goal is for the person deciding, it's to decide the right human, and for the human playing, it's to get decided. So in my mind, the decider could always say, oh, they could kind of invert the test and say, please ask me a question that you know the chatbot is not, like ChatGPT, or for instance, like ask me to describe some horrific, you know, racist, whatever thing, and the human could then, you know, for ChatGPT, it's easy to like produce language that ChatGPT wouldn't produce. So if there's knowledge of the system, it's in some sense easy to still deceive or to still break the Turing test constraints, because unless there's a lot of constraints put on what can be asked and said, that there's always like, if you have knowledge of the chatbot and what it's allowed to say or not, and obviously no one would ever train a chatbot to generate, or, you know, we hope, to generate like really inappropriate things. Like that's a part of the strength and weakness of it, is that we want to restrict what it says and why it says it. And those restrictions are easy to circumvent for humans because we have no such restrictions, only moral and ethical ones, no actual implementation restrictions in some sense.
Yes, and I mean, we don't really know how the brain works in many respects. So unlike a chatbot, which after all are following, we know much more about chatbot and then we can know about the brain. But still, I think that's one of the problems, that they also work because of the deep learning. They work like black box, so it's also hard to know. But I think if one really wanted to develop something that was very good at the Turing test, and one didn't tell at all how that was done, I think it could work quite well in a Turing test.
Yeah. But then I guess the question is the Turing test, is that what we want to achieve from a system? Like,
No, of course not. Of course not. I was thinking, if one wanted to challenge that test, it's probably possible to do it.
Yeah. But in some ways it would violate some ethical principles along the way, some kind of, I forget what, you know, like doctors take this oath to the ethics, and it's like, you know, you don't want your chatbot to be saying like really, you don't want it to be saying hate speech.
No.
So, but in order to like pass the Turing test, hypothetically, you would want to program it to be able to produce hate speech, and because it's an arbitrary set of questions that one can, I don't know. But yeah, and then just to kind of keep with this historical narrative, we can talk about the actual 1956 conference at Dartmouth, with people like Marv Minsky, Simon Newell, etc. Do you know much about that conference? And
No, not really. Except that I think some of the people thought that it would be easy to achieve the goals of AI within a few years.
Yeah,
I remember, which of course was completely wrong.
cool. So, and now we can get to the actual meat of the conversation and talk about intelligence and what intelligence can or should mean. So it says the goal of AI is aimed at implementing intelligence in a computer in this Stanford Encyclopedia article. But we need to investigate what is intelligence. And I think one of the things that's happening with all the hysteria in the news is there's a lot of kind of loose terminology being thrown around that, you know, artificial intelligence is one of these highly ambiguous phrases that means different things to different people. And I think this is a big problem because there's no way of grounding the conversation when two people have a different an entirely different notion of what's in their heads. So, yeah, like how do you think we should go about trying to construct a definition or a notion of intelligence that's both suitable for like humans, but also for machines and or programs?
I think it's really very difficult, and I'm not sure if there is a good definition of intelligence. I have always a rather biological perspective, and so I mean, our brain obviously has been developed for survival, and our thinking is of course an important part for our survival. And intelligence is connected with this, I would say. Smart strategies for survival, and also involving a certain amount of computational the possibility of doing computations, but that's not an important part of it. It's all these other ingredients that is important. So I think this is connected also with the notion of consciousness. There are some who are discussing this and about consciousness, but there are usually quite strange ideas because there is no definition of consciousness. That's even harder than intelligence, perhaps. I think that opens up for the possibility of coming with very strange ideas when it comes to consciousness.
Yeah, so do you think that intelligence should be seen as a derivative of consciousness,
No,
exclusively?
No, not really. But I think that for us, consciousness is extremely important.
Mm-hmm.
And intelligence helps our survival. So that's the biological perspective of it. And I'm not sure if that could lead to intelligence in general. I mean, cleverness or whatever you would call it. But it's definitely not this computational intelligence, which I think is really important.
Okay. So, yeah, I mean, this is something I'm really curious about because let's take an example that might be seen as a counterexample, which would be a virus or a bacteria, because they're clearly a virus. It's, you know, debated, I guess, whether or not it's life, but a lot of virologists, I'm told, say that it's not because it can't live independently of a host cell that it infects or inhabits. But I was talking to this virologist a few weeks ago, and she mentioned how, like, she said viruses were clever, and it's like a virus is not just, you can't describe it with the tools of raw physics or chemistry, that the RNA is so complex that it has all these emergent behaviors that aren't reducible to simpler kind of more deterministic systems. And I think that it's not to say that we should call a virus intelligent or not, but it's more to, yeah, kind of need the word to determine what about a virus is intelligent or isn't, or a bacteria, because clearly they possess a lot of clever behaviors if you ask a biologist. I'm curious what your thoughts are.
Yes, no, I agree. I don't think that it has to do with this, with the survival. And of course, what a virus, their so-called intelligence must have to do with that they want to spread, or rather statistically, It are those that manage to spread that will survive, those that will dominate. And of course, I don't know how they work, but there seems to be some really incredible things going on if you look at the recent pandemic and all the new forms that develops. It's hard to understand what's going on. I wouldn't call that intelligence, but it's certainly a behavior which is very efficient for them to spread.
Mm-hmm. But I mean, I guess this is a lot of my thoughts are what is like, how can we distinguish intelligence from life itself? Like, what properties of life are intelligent versus just more just raw life? Like, I think this is like something that hasn't been asked enough, or at least I haven't been seeing being asked.
So life seems to be an easier thing than, for instance, consciousness and these things, because there is an chemical definition of life made by some Hungarian. I don't remember exactly, but I read about it recently. So there is a theory of life which goes down to the chemical level, which when I read it, I found it rather convincing. So I think the concept of life is much clearer than that of intelligence and consciousness and that things.
Mm-hmm.
It's possible to give a definition of life which seems reasonable, which was new to me when I read it fairly recently. I can send you that name of that. I think it was Hungarian.
Yeah, I would love that.
And I think this was, I mean, some 20, 30 years ago or so. But he's clearly a big figure in this area. And there are some very distinct definition of what is life and what is not life.
Yeah.
Which
So,
came as a surprise that you really could single out life fairly easily, which is much harder for another concept. But there, if we take consciousness, that's extremely much harder to get hold on, because we cannot do any test on that really. And it's something extremely subjective. And but life we see around us, but I will send you that reference so you can have a look at it.
Mm-hmm. Because I mean, I think one of the big questions of artificial intelligence, right? It's like, can there be an intelligence independent of life? And are there properties of LLMs or computing systems that are lifelike? Like they only reproduce in the sense that we produce them. We are the ones who manufacture these circuits. We are the ones who program them to produce, to compute. So in some sense, I think these LLMs have very few lifelike properties because there's no notion of DNA inside of them. There's no notion of replication. It's like we're doing the replicating. We're writing a paper, adjusting some hyperparameters, some architectural things, some data training set, whatever. And but there's no notion of reproduction inherent into these so-called artificial intelligence systems. I'm curious. Yeah.
So I find it very difficult to see that they in any sense should be alive.
Yeah, exactly. So yeah, can we decouple intelligence from life? Like is intelligence I guess the questions are is what is intelligence, what is life, and what is computation? And how can we kind of blur those versus see them as separate categories?
Yes. No, I think intelligence is a very vague concept if you're looking at it from all these aspects. I mean, we know when we use it in everyday language roughly what it is. If we say a person is intelligent, we can precise it in various ways, but I think we have a pretty good idea what it is. But when you extend this to, well, for instance, if you go outside that, then it becomes very hard. And also animal intelligence, I think there must be many concepts going on at the same time here.
Yeah, and I mean that's fine to just say, okay, there's distinct subclasses of intelligence. But even then, I think if an artifact is to be considered intelligent, the subclass, like the intelligence between apes and humans, like there are two different notions of intelligence there, but they're quite similar. Like humans basically could be seen as like apes with an evolved language capacity, and that's like what gives us human intelligence over ape intelligence.
Yes.
But
Yes.
but computers, if you compare like computers to apes, then there's really very little similar. Like ChatGPT has nothing at all similar to do with an ape. So if we want to interrogate what is an artifact's intelligence in that sense versus an ape's or a monkey's in general. So I think one of the big things that I was preparing for is, yeah, looking at definitions of intentionality and extensionality, which are commonplace, I guess, in philosophy and type theory. So for listeners, we can, yeah, just begin by defining what do you think of intentionality and extensionality?
So what do you mean by intentionality and extensionality in this context?
I mean, we can start with the logical, like, let's start with a more limited scope and look at it in terms of logic and try to, like, if intelligence is definable property of a program, then it should be formalizable in some system, I guess, in my mind. So yeah, like, if we say like equality, right? So there's this famous example from Paramarts and Love's like 2 plus 2, 2 times 2, and 2 to the power of 2 are all equal to 4. And they're very different intentional notions if you just look at the syntax and
Yes.
the tree that gets evaluated when it gets computed. But when you say 4 is equal to 4, when they are evaluated, then they're extensionally all the same. If you look outside the system, you don't know which operator was used when you give the arguments 2 and 2.
But how does this connect with intelligence?
I guess the question is do we want to look at intelligence as an extensional behavior thing, like the Turing test, where you're just purely looking at inputs and outputs, versus do you want to see it as an intentional, like the human versus ape thing? When we look at a human and an ape, they don't have necessarily the same extension, like an ape can't talk, but we know that we behave in a lot of similar ways. We have a similar neurological makeup. We have bodies that are, mirrored to some degree. And so when we talk about intelligence with different animal groups, it seems to be a more intentional notion. Whereas when we use like these Turing tests, or like when I think a lot of the computer scientists talk about intelligence, they're using an extensional perspective. I don't know if that clarifies it.
Yes. Yes. So I think people, well, it's really a complex subject, and it's difficult to, I guess one can have both views. I mean, if you look at intelligence tests and things like that, they must be extensional, I guess, showing results. But I have not been thinking enough on that. But I agree there is certainly an interesting distinction.
Because I mean, I think if you take this extensional view, the problem is that it collapses because all of a sudden, any kind of basic computer, like a program to calculate the digits of pi could be called intelligent because it produces an output that's you know, very accurate, and even it performs better than a human on this certain task. But, you know, this is where this notion of general intelligence comes in. But yeah, I guess my question is really about this, and it's not just to you, but that I've been asking is, if you have this extensional view, like what makes a LLM unique compared to other programs?
No, I agree with what we talked about before. One must be more precise with what we mean by intelligence to be able to. I think it's a rather fuzzy subject.
Yeah, and it seems, and that's my point as well, is that it's like as soon as you start to put more restrictions on the definition, it's like you either have too loose of a definition or too tight of a definition on intelligence. And that if you kind of try to admit both the loose and the tight definition, then either seemingly everything becomes intelligent or nothing is intelligent. That it's hard to come up with a clear definition that doesn't have some counterexample somewhere.
Yes. No, I don't know what to say, but of course this is important to what you mean by artificial intelligence, and in some ways what we call AI has nothing to do with intelligence, depending on how you define this.
Mm-hmm.
But it's rather interesting that Turing could have had such a simple view on these things. The Turing test is, after all, really not addressing any of these questions in a deeper sense.
No, and I don't think he references intelligence as such. He says think, and right, it's can machines think is the kind of purpose of his paper. It's like, is
Yes.
the deceiving machine.
Perhaps this is not too far away from intelligence. If you can think, then if you do that in a correct way, so to say, then you have some intelligence.
Mm-hmm. So yeah, I guess one of the questions too about this intentionality or extensionality would also be like Searle's Chinese room argument, and
Yes.
the fact that extensionally you can have this program, you know, if you have some giant syntax lookup table that gives you, that you can use to like write Chinese even if you know nothing about it, and deceive someone into thinking you're intelligent. That's an extensional property. Like they don't see you, they just see that you
Yeah.
produce something that's coherent.
Yes.
And I'm curious how you think of ChatGPT or any other LLM in terms of this. Is it just a syntax generation? I mean, it clearly has semantic content, but that may not be intrinsic to the system itself. That's just intrinsic to the data that it somehow samples it in the right way to make it coherent to us.
I really don't know. I'm extremely impressed that those that have programmed these chatbots have been able to do something that functions that good. I mean, there must be a lot of things happening which we don't see. A lot of
Yeah.
decisions they have made which we don't see.
Mm-hmm.
But no, I don't think this has much to do with intelligence, if anything.
Mm-hmm.
Because it's after all, it's purely mechanical, although there is an important statistical element in it. But it's, I mean, it is really deep learning applied in a very clever way
Yeah.
on enormous data sets.
And I mean, the data sets themselves, like, what's to say that a huge data set isn't intelligent in the same way that a huge library isn't? Like, you can go to a library and look up references, find a book, read it, and it'll reference other books in the library that you know, it's like you're doing the work by going and taking the books out the shelves, analyzing a text, taking notes, synthesizing your thoughts, responding to it. And you can think of these data sets, yeah, like a library of text from the web. And then you're just applying this algorithm to, you know, determine some kind of nearest neighbor correlation of words. And if we say what's intelligent, is it the data set, the architecture, training algorithm tuple, fine-tuning, you know, like, is it just the data set itself? Is it the architecture and the weights? Is it it's only the end machine that's intelligent? I think this is also another conundrum.
Well, I think it's strange to use the word intelligent in this context because I think it is something different.
Mm-hmm.
It's really a program that generates things from a lot of data, which well, for us looks coherent and I mean, it's very impressive that it can produce such things as it does. And I must admit that I think they have been very clever, the people that has been developing it. But I don't know really the history behind it because it could have been going on for many years with how one should build up such things and what to output from it.
Yeah.
If you see the end result that many of us do today, it's really quite impressive.
Mm-hmm. So I know our time is about wrapping up. I don't know if you have 5 minutes to kind of tie it back into some type theory ideas. I can ask one or two more questions.
Yes, we can have 5 minutes more, but I think we should also perhaps continue this in some way. I didn't have any time to look at these things, and I could look at it a bit more careful.
Yeah, I mean, this could be a warm-up. I would love to interrogate, you know, each of these points, or even, you know, go through a few of these publications and really ask, like, what is the Turing test? What are its strengths, weaknesses, iterations, etc. But I
Yes.
mean, yeah, so we can definitely have another conversation. I'd love to do that. But the last thing I wanted to talk about is just yeah, verification. Because when you come from a type theoretic background, you know, I think my takeaway from all of Per Martin Löf's work is like, what is evidence? What constitutes evidence in a formal sense? And when we have these chat bots, they have evidence that they work sometimes, but then they also hallucinate. And it's like if you were to, you can't formalize a program in Agda or a strongly typed proof, you know, interactive theorem prover that would deal with hallucination. You can't say like, you know, for all inputs of this sort, the output will be of this sort, because the system is so ill specified. It's just specified up to the training data or to the weights, that there's no notion of verification other than that, you know, it performs well in certain things, and then it also makes arbitrary errors all the time as well.
Yes, I think it's really something completely different. I mean, if you look at these meaning explanations and all these things, it's done very detailed systems where you have, rather basic logical systems. Well, they could include mathematics too. Type theory is, of course, intended to be something general, but it has nothing of the complexity that you find in these large language models and the use of them. I mean, it's really down to details, to have a precise meaning down in on the detailed level where you have a very clear syntax and all these things. For me, it's something really completely different.
Yeah. But I mean, here's the thing, it's like you wrote this paper about evolution and logic, and yeah, this is another thing we can talk about if we have a future discussion, but do you think there's any possibility that we could somehow make a claim that a large language model has internalized logic, like that it can recognize an and or an or a universal quantifier in the most general sense that a human can? And obviously humans are subject to error. We're not like precise logical machines ourselves, but we have an intuitive notion that we've been able to refine and formalize coming down to Frege. But do you think there's any hope of, because I think this is, for me, one of the only hopes of verifying a system is if you can like show that it's internalized some sense of some type of logic or type theory.
Yes, but it seems to be a very difficult task to figure out that such a system.
Yeah.
Or to and also we must remember that we are in the very early days of these large language models. I think I've been looking a little bit to GPT versus GPT-4. There seems to be a very big difference. The GPT-4 is much better.
Yes.
And I was thinking of perhaps look at that a little more carefully, try it. You have to pay a bit, but not very much to get the system. And because, but the example I have seen it's really quite impressive. But of course, it all has to do that you have an enormous amount of data that you are combining in a clever way. So it's not, these hallucinations that you mentioned, they are of course very quite strange when you see them, but it must really be an imperfection of the system that they are even allowed to do things like that.
Yeah, but I mean, it's also like a strength of the system that you couldn't to design it to not hallucinate would be to impose an a priori set of constraints that would have to be subject to some logical laws.
Yes. But I should send you this about life, this Hungarian, and perhaps we should have another meeting, but at a later time.
In the fall or.
And you could send more precise question if you want.
Okay.
As a starting point.
Yeah.
But I mean, I didn't have time to look at this. But on the other hand, if I looked at it, it's some of the questions here are of course extremely difficult, so it's not sure.
Yeah. I mean, I'm trying to clarify these thoughts for myself as much as I am for anyone else, you know.
Yes.